So this last video is just to make an important point about our spreading equations, the two that we've worked on in the last couple of videos and hopefully now feel somewhat comfortable with. And that is the fact that solutes or pollutants or chemicals, they don't mix in a river instantly. They don't fill the river from bank to bank for some distance that is called the mixing length. So these equations, they only work after the mixing length, that is after the river is filled bank to bank with the chemical or pollutant. So then how do we predict this length of time or distance over which these equations won't work? So here is the equation for predicting that. Here we have the length of the mixing zone. It's called a transverse mixing zone or mixing length. V is the river velocity, average river velocity, W is the river width, and dt is the transverse Fickian mixing coefficient. So that transverse just means this way versus the longitudinal one, which is what we were talking about before. Okay, so dt in general is something that I'm going to give you. There are equations and characteristics that you can use to estimate them, but we're not going to spend too much time worrying about them here. Okay, so here again we have our two main processes with the main equations for those. And again, just want to point out that if you have a conservative tracer, k is just equal to 0. That means there is no decay, and this just goes to 1. So we end up with just this portion of the equation essentially to work with. And then this last point was the fact that these equations, they only work after the mixing length, which we can calculate with this equation as long as we know the transverse mixing coefficient. And that is the last of your videos for this time.